Hi, this is the ICAVE subgroup, part of TAM, a supergroup that deals with virtual and augmented reality. This particular project would deal with learning with virtual reality. This project is not the first to use the ICAVE, although it was the first in this particular project. To solve the goal of learning with virtual reality, we've decided to create something that allows the user to physically interact with the environment that is the ICAVE. In this regards, we have tried to create a sailing simulator which will teach the user how to sail. As you can see with our Gantt chart here, the majority of our early assignments were research-oriented, learning how to use the ICAVE and learning how to use different aspects of Unity. And as you further along in the project, a lot of features began to be implemented. More and more time began to be used on developing for Unity instead of researching how to actually use Unity itself. We have many user stories that show the implementation and thought process behind what we thought should be added. Most important of all would be controlling the ship, enhancing it so that it feels lifelike, so that it feels like an actual simulator. More enhancements to restrict the player movement, making sure they don't get stuck on the ship or being able to jump off. There were also many animations that we had to create, such as turning the wheel, the floating effects of the ship, and objective creation, something for the user to actually do to traverse through a map that we've created. The user had to not collide into anything, or if they did, it would stop the ship and the environment itself. Here we have our use case diagram. The player is able to enter the ICAVE and start their sailing simulator, navigate through the environment and collect each objects, and ultimately exit the simulator once they've reached the end of the level. The developer can do the same to test their project or go into Unity itself and manage the simulator outside of the ICAVE. Here we have our sequence diagram that follows the state of the project. As the user controls the ship gets affected by both the active and the static environment and continues on with the level. Our system design is Unity's component architecture, where everything is a game object and all game objects have many different components attached to them that affect the behaviors of each specific game object. It is also partially service-oriented architecture where different managers individually do services and interact with one another. This design is considered very standard in the Unity community. Here we have our system deployment and deployment diagram. These different things are required to run our program. Mainly the ICAVE and controllers, but also Unity and GetReal 3D if you plan to develop for the program. Ocean View just happens to be the name that we've given the project that we've been working on and the different aspects contained within it. Here's a class diagram of the most common interaction in our project. The player ship, the active environment, and the UI manager all affect each other in some way. Here's a few samples of code from our project, different algorithms for different aspects of the project. Again, continued. Next we have sample test cases of things like ship movement, the animations, the player moving around the ship, the environment itself, the objective, and the collisions between the ship and the environment. These are the most important aspects of the project and the parts that needed the most testing. Lastly, we have some screenshots of our project to give an idea of what it looks like. Here is the map that the player will have to traverse, just a small sample to test the aspects of our program. And here is a first-person view of the program itself. You can see the ship itself and the UI that we've implemented